this one is just another video on the binomial theorem. So some of it will be new and some of it will be review. So if you feel comfortable with the theorem itself, you probably can breeze through the videos. But I'm going to add on a new concept also. So this is the new part which I didn't cover in the third video. And it will ask you to find the coefficient of x to the fifth in the expansion of 2x minus 7 to the ninth power. Okay, so first of all, what in the world is a coefficient? And if you don't know what that is, remind yourself that that's a number in front of a variable. Okay, so if you had 2x to the 7th, your coefficient is that 2, right? So when you think about the binomial expansion, your power obviously is important. So if I have a ninth power, I'm going to do 9 choose whatever, and then my a is 2x, and my b is a negative 7 since I'm subtracting. And I don't know if you noticed, but in the pattern, if I'm finding like 9 choose 4, then my 2x will be raised to the difference between the 9 and the 4. So, and that's what r is for, because I want to find the x to the fifth term. And well, think about this, I guess. If you have x to the ninth, you're going to have x to the ninth, x to the 8th, x to the 7th, x to the 6th, x to the 5th. And so that would be matched up with, of course, this would be 9 choose 0, 9 choose 1, 9 choose 2, 9 choose 3. Oops, if I can write. 9 choose 3 and 9 choose 4. So notice that the combination number and the power of the first term always add up to 9. 8 plus 1, 7 plus 2, 6 plus 3, 5 plus 4. Or the difference between these is always what you're choosing. 9 minus 9 is 0, 9 minus 8 is 1, 9 minus 7, 2, 9 minus 6, 9 minus 5 is 4. So there's definitely some pattern to it. Good news if you don't see or understand that pattern necessarily is you can do what I just did and lay it all out if you need to. But I know that the x to the fifth term, so when r is 4, then I know that I'm going to be doing x to the fifth term, I know that my combination choosing is 1 less than, well, the sum should add up to 9. So if I want to find the fifth term, I know that my combination piece is going to be 4 because 5 plus 4 will add up to 9. So that's where all of this came from and how I knew r was 4, so just a little explanation behind that. So I would go ahead and find the coefficient. So to find the coefficient, I would have to go up here, right, and I would have to do 9 choose 4 times 2x to the 9 minus 4, which would be 5, and negative 7 to the 4th. So you would take 9 choose 4 on your calculator, 2x to the 5th would be 32x to the 5th, negative 7 to the 4th, well, is a large number. That's negative 2,401. So you'd multiply all of these together, and I'll walk through that again with another problem. Before I do that, there's a couple more expanding, and this is really just if you needed a little bit of practice. I'm going to write out the answer for both of them. I will talk through the second one, and if you're stuck on the first one or something doesn't make sense, let me know. But I'm going to, again, pause the video, and I really want you to practice these before you listen to me explain anything. So go ahead and pause the video and see how you do using the binomial expansion theorem. Okay, so the first one I wrote out everything in purple, and then the final answer is in orange. So again, your power was 3, so 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. First term is a, so start cubing, square, first, 0, and b is 2b, so 2b to the 0, 2b to the first, 2b squared, 2b cubed. Things to be careful of course, is, 2b cubed is really 8b cubed. This is 1, this is 1, this is 1, that's 1, so that's where you got a cubed. This is 3 times 2 to give you the 6. This is 3 times 4, because 2 squared is 4. 3 times 4 is 12. This is 1. 2b cubed is 8, so 1 times 8 is 8. And that's it. Okay, and last but not least, here's a coefficient one. So see how you do, except for I left off the power here. This is to the 10th power. Sorry about that. Hopefully you can read that. Anyway, that's to the 10th power, mental note. So you need to find the coefficient of x to the 8th in the expansion of 3x minus 2 to the 10th. So see how you do. See if you can think about this pattern and get there. Okay, so what I've laid out here is just kind of the idea of the pattern. So you have your 10th power, so it's going to be n choose r. Your first term is always the difference between these two as a power, and your b is always whatever the r is. So if you want to find x to the 8th, I always start with the a, because I know that this has to be x to the 8th. So my x term is 3x, and I know that that has to be 8. I also know for sure that n is 10 because my degree is 10, so that's a kind of a freebie. So again, I know that this 10 minus something has to be 8. Well, I know that that has to be a 2, so this has to be a 2, and my b value has to be a 2. Now if you get that pattern, that's much quicker than going the other route, which is where I laid it out starting with 10 choose 0, 10 choose 1, 10 choose 2. I knew I wanted to get to the x to the 8th coefficient, so I stopped there. But no, these are the same things, and if you get the pattern, you wouldn't have to lay it out. Like what if I wanted x to the 5th? You would have to lay that out quite a bit. And then last but not least, simplify that. So 10 choose 2 is 45, and 3x to the 8th, well 3 to the 8th, that's a big number, that's 6,561 x to the 8th, and negative 2 squared is a positive 4. And when I multiply all of those together, I get 1180980, and that would be the coefficient of the x to the 8th, a very large number.